the bit error. So what is this? To deal with the data corruption, to deal with this concept, to deal with the scenario of third party entering and corrupting the data, we have the solution introduced for this in RDT 2.0. And what is that? Who has introduced this? It is TCP running at the sender side, TCP running at the receiver side has introduced the concept of acknowledgement. And what is that acknowledgement? We have two types of acknowledgement. One is positive and the other one is negative. So what is positive acknowledgement means? If the sender sends the data to the receiver and if the receiver is properly receiving the data without any corruption, then in that case the receiver should send back which acknowledgement? Positive acknowledgement. And suppose if the data is sent to from the sender and the receiver, when he is receiving, if he is receiving erroneous data, that means if third person is corrupting the data and if receiver is receiving erroneous data, in that case the receiver should send the negative acknowledgement back to the sender saying that the data is not received in a proper order, proper format. So this concept of acknowledgement is introduced in RDT 2.0 to deal with this bit errors. So we will see that again. What is it? Okay. See, you can just see this RDT 2.0. This is represented with the help of finite state machine or transition diagram. So first we will deal with the sender side. So what is happening at the sender side? Then we will go to the receiver. Okay. So what is happening at the sender side? So you can just see we have the first state at the sender as usual, as same as how we had in RDT 1.0. So wait for the call from above. So what is this wait for the call from above? Wait for the message to arrive from the application layer. So once the message is available or the data is available at the transport layer, we have once the message is available, you can just see the same operations what we have there. We have the same operations we have, that is RDT send is the first operation invoked at the transport layer, and then we have after that the same concept here. The sender has to make a packet, that is he has to create a packet, and then once he creates the packet, that packet should be sent to the network layer, that is below layer at the this side. What is that? Sender side. Okay, and once we have that, you can just see here. Yes, where are we? Yeah. Once the message is arrived at the sender side, we have RDT send that is invoked. You can just see. Where is it? Yeah, and once that data is available, the transport layer at the sending side, that is TCP running at the sending side, should create a packet, and in that packet he has to insert the data that he has just received from the application layer. And along with that data, in order to deal with these errors, as I already explained, the sender should add a checksum and send. So how to deal with this corrupted data? He has to deal with the corrupted data with the help of a checksum that is existing. So, and what is checksum? I have already explained what is checksum there in the UDP concept, right? So the same concept is used here also. Any technique can be used for for generating the checksum. There are many techniques for generating the checksum. Add checksum along with the data, and that packet now you have to send it to the network layer at the sending side. So UDT send is the operation to send the packet at the network layer. And you see here, once the packet is sent to the network layer at the sender side, the sender will go to the new state. And what is that state this time? Waiting for the acknowledgement to arrive. And here we have the acknowledgement concept introduced. So wait for the acknowledgement to arrive. So two types of acknowledgement you may receive. What is it? One is positive and the other one is negative. You can just see here the transition happens from the old state to the new state of waiting for acknowledgement. And now you can see there can be two things happening here. One is the sender whatever he has sent might be received at the receiver side in the proper format without any corruption, without any problem. He might have received. In that case, what acknowledgement he may expect? In that case, he may expect a positive acknowledgement. And one more concept is what? The data whatever he has sent might be corrupted by someone, and in that case the receiver might receive erroneous data. And if the receiver receives erroneous data, what the receiver will do? He will send you the negative acknowledgement. So two possibilities. So what if the sender here receives negative acknowledgement from the receiver? So we will see that. What if sender receives negative acknowledgement for the data that he has sent just now? So if the acknowledgement is negative acknowledgement, you can just see here, the sender will invoke this event. What is that event? RDT receive, and he has just now received an acknowledgement which is also in a packet format. He has received an acknowledgement in the form of a packet. Why? Because he has received the acknowledgement from the network layer at the sending side. See here, receiving is happening from bottom to top, right? So bottom layer is network layer, from bottom packet is just now received, and that received packet he will check if it is a negative acknowledgement. You can see logical and operation is used. What is it? Logical and? Both the condition should be true, then only you can get the answer true. What is meaning of both the true here? If you receive a packet from the network layer at the sending side, and if that received packet, if it is negative acknowledgement, both are true, then what is the meaning of that? Sender will understand that the data what he had sent might be corrupted. So what is the operation that he has to do? Now if he comes to know that the data what he has sent is corrupted one, what the sender should do? He has to retransmit the data. So how the retransmission is done? See, he has to just call the operation UDT send packet. What is the meaning of UDT send packet? The same operation we had used earlier, right? So what is this UDT send means? We had already created a packet for the first message that was arrived, and for that particular packet we had added checksum, and that is already stored in a variable called send packet, and that send packet we had directly sent by using the function UDT send. So this was the function that was used to send the packet for the first time, right? So here now you are retransmitting the packet. Why? Because the received packet is erroneous one. So this retransmission is happening directly. So we have already stored the packet in a variable called send packet, and now all you have to do is retransmit it by using UDT send, because this time you are also you are sending the packet to the network layer again at the sending side, right? So UDT send is the function that you have to use directly by inserting the variable send packet. And you can see here, immediately after sending the negative acknowledgement, he is again going back to which state? Again he is waiting for the acknowledgement to arrive. This time he is waiting for which acknowledgement? He is waiting for this retransmitted data's acknowledgement. He is waiting for the acknowledgement of retransmitted data. So this loop is written for that purpose. So what is that? After resending the data, again he has to wait for the acknowledgement to arrive. So again you can see here, this is one possibility. So sender has just sent the data. After sending the data, he will just wait for the acknowledgement to arrive. And we have seen in that one possibility, sender might receive negative acknowledgement, and we have seen what to do with that. And now there is one more possibility. If the sender receives positive acknowledgement, what is he doing? If the sender receives positive acknowledgement, you can just see how this is written. Same way how this functions, how this condition is written. The same way this is also written. RDT, he is receiving the packet. He should receive a packet from the network layer at the sending side. And if the received packet, logical and, if the received packet is ACK means what? If he is receiving positive acknowledgement. If the received packet contains what? Positive acknowledgement. Earlier we had checked for what? Negative acknowledgement. This is what? Positive acknowledgement. Only this is the only difference in the condition here. So received packet, if it is positive acknowledgement, what the sender should do? Sender should do nothing. See, this indicates, this symbol indicates do nothing. So sender should do nothing. All that he has to do is he will move back to the first state. What is that first state? Wait for the next message to arrive. And once the second message arrives, again the operation continues. Create a packet for the second packet and send that packet to the below layer. Again move to the new state of waiting for the acknowledgement. So I hope this is clear with respect to sender. Now we will move on to the receiver. What the receiver will do here? Receiver's job is what? Wait for the packet to arrive. See here at the receiver side, bottom to top the operation is happening. First here the network layer will receive the packet, right? At the receiver side. So once the network layer receives the packet, network's layer job is to send that packet to the transport layer. So what the receiver does, what the receiver does here, so he will wait for the packet to arrive. So receiver's transport layer will wait for the packet to arrive from the network layer there, and once the packet arrives, he has to just check for the packet now. Packet's condition now. What is the meaning of packet's condition? Is to just check whether the data that is received is erroneous data or not. Correct, no? So he will just first check. We'll see this first condition. Receiver will receive a packet. And if that received packet contains corrupted data, how will he come to know that the received data is corrupted or not? With the help of checksum what the sender has sent, and we have already seen how the checksum is dealt here at the receiver side. So received data will be added with the checksum, and that result may be one's complement of that might be taken. So that is one simple way of using this. There's a simple way of detecting the error there. Likewise, many such techniques are there to detect the errors with the help of checksum. Okay, so you can just see here. So received packet, receiver will see whether the received packet is corrupted one. If the received packet is corrupted one, what the receiver should do? Nothing. He has to simply prepare negative acknowledgement and send. So that is what he is doing. This is the event occurring, and what is the action he is taking? He will just prepare a negative acknowledgement, and remember UDT send is the operation used. What is the meaning of that? Negative acknowledgement, whatever he has prepared, he should send that acknowledgement to the network layer at the receiver side. Network layer means what? Now top to bottom the acknowledgement travels. So at the receiver side, from transport layer, the acknowledgement packet should go to the transport layer. So from then onwards it will move back and reach the sender. Okay, so now UDT send is the operation that is invoked, and wherein he is sending the negative acknowledgement. This is one possibility. After sending the negative acknowledgement, what the receiver should do? Nothing. He should wait for the next packet to arrive. Correct? So this loop is shown here to say that the waiting for the next packet to arrive. There is one more possibility at the receiver side. What is that? Receive the packet and he'll check whether the received packet is corrupted. If it is not corrupted, what the receiver will do? If the data is not corrupted, he doesn't have to do anything. He will extract the data out of the received packet, because the message he is interested in it. He'll take the message from the packet, and that extracted data he should deliver to which layer? At the receiver side, he should deliver that data to the application layer for the receiver, for the user to read. So here he will deliver that packet, or not packet, he will deliver the data out of the packet, that extract out of the packet, and that extracted data he will deliver to the application layer. So delivery, this correct data is delivered to the application layer, and don't forget this last line. What is it? After delivering the data, receiver will send the positive acknowledgement back to the sender. So this UDT send is invoked to send the positive acknowledgement to the network layer at the receiver side. Through the network layer, it will go to data link, then physical, then finally it will fly to the sender. So these are the two operations. So after sending the positive acknowledgement, what the receiver will do? It will go back to the previous state. What is it? What is the state? Wait for the next message to arrive. So here you can see at the receiver side only one state is there, but he will check for two possibility. One is corrupted one, other one is not corrupted. So positive and negative acknowledgement is sent accordingly. So this is how you write the finite state machine. Okay, so on RDT 2.0, you just remember one term that is checksum. So what is it? It will just deal with the erroneous data. It will just check whether the data that is sent is corrupted or not. So for that, to do that, you have an acknowledgement concept introduced. So acknowledgement, checksum concept introduced, along with that acknowledgement also. So receiver will send the positive acknowledgement if the data is correct one. It will send the negative acknowledgement if the data is corrupted. Okay, so this is what you have to remember. So I hope this concept is clear. So you can just see the operation here. Wait for the call, and then you can see wait for the call from below. See, this is how the operation takes place. First at the sender side, waiting for the message to arrive, then comes here waiting for the receiver side. You can just see the data is just arrived at the sender side, and once the data is arrived, next what happens, that data will be sent to the receiver, and what the receiver will do, he will check whether that data that is received is corrupted or not. So if the data is not corrupted, what the receiver will do, he will send the positive acknowledgement. And if the data is positive acknowledgement, if the data if the packet is positive acknowledgement, this is the operation that is invoked, and it will go back to this state, correct? No? So suppose here again wait for the next message to arrive, and if the next message that is arrived, you can see if the next message that is arrived is a corrupted data, you can see a red arrow moving from sender to receiver saying that the data that is arrived is a corrupted one. If the data is corrupted, what the receiver will do, immediately will prepare a negative acknowledgement and send, and that negative acknowledgement is received by the sender side and received by the sender. And if it is negative, what he is supposed to do, he will just resend the packet, and this time once he is resending the packet, again that resent packet will be received by the receiver, and again if that packet is received in the proper order, that positive acknowledgement will be prepared at the receiver side, and that positive acknowledgement will be sent to the sender. And you can see once he receives the positive acknowledgement, now the sender is ready to send the next new packet. Okay, so that is the concept of RDT 2.0. But RDT 2.0 also has some disadvantages. So what is that disadvantage? See, one of the disadvantages, here we have dealt with only data that is proper, whether it is corrupted or not. But what happens if the acknowledgement gets corrupted? If the acknowledgement sent by the receiver gets corrupted, in that case, sender should know, first of all, whether the received acknowledgement is positive or negative, correct? If the acknowledgement is garbled, then the sender should understand first of all what is this garbled one, whether it is positive or negative. So accordingly the sender should take an action, correct? So if he assumes, so what are the different possibilities there at the sender side if he receives garbled acknowledgement? If he receives garbled acknowledgement, sender might assume many things. What is that? First thing is, the received acknowledgement, he might assume that it is a negative acknowledgement. And see, if when somebody speaks to you and if you are not able to understand what he is speaking, what are you going to say? You will just request him to say it again, to repeat. You will request the person to repeat, right? Because you have not understood what he spoke. Same way here also. If the sender receives a garbled acknowledgement, he may request the receiver to send back, resend the acknowledgement. That is one possibility. The other possibility is the sender may assume that the received garbled acknowledgement is negative acknowledgement. So if he assumes it is a negative, what the sender should do? Sender will retransmit the data. But you see here, the acknowledgement is garbled. The meaning is what? Receiver might have received the data correctly. But the receiver, after receiving the data correctly, he might have sent the acknowledgement also correctly. But the acknowledgement on the way got corrupted, where receiver is not aware about that. Sender also is not aware about this. Sender will think that this acknowledgement is received from the receiver. See here, both are not aware about this garbled one. So receiver, sender, what he should do? He should tell the, notify the receiver that the acknowledgement is received, but it is garbled. How is he going to notify? Nothing, no other way. He will retransmit the packet. So retransmission means what? Earlier whatever he had sent, he will assume that this garbled acknowledgement might be a negative, and he will simply retransmit the packet. But once he retransmits the packet, what happens there at the receiver side? Receiver side, it becomes duplicate packet. Why? Because receiver has correctly received the packet, and for that correctly received packet, he has sent the acknowledgement also. But problem is at the sender side, he is not able to understand, right? So receiver cannot accept the same packet again. Already once he has received, acknowledgement also is sent, again he cannot receive that packet, right? So the receiver should identify the duplicate packet arriving, so that receiver can discard that duplicate packet arriving. So that concept also should be introduced. So handling, how to handle duplicate packets. So when the duplicate packets will come, only when sender is retransmitting the packet. And when the sender will retransmit the packet, one is only in the case of negative acknowledgement. When the negative acknowledgement is sent, that is when the receiver will receive corrupted data. Or if he is not receiving corrupted data, the acknowledgement what he has sent, if it is corrupted, in that case only the sender will retransmit the data. But at the sender side, if the received data is in a correct format and he cannot, in that case he cannot receive the duplicate data. So twice the same data he cannot accept it, right? So duplicate data at the receiver side should be handled. So how to handle with that duplicate packet, that is the problem now. So that problem cannot be dealt here in RDT 2.0. So for that, a new version should be used, or you can say a new principle should be added, a new solution should be given for handling such duplicate packets. So what is that duplicate packet? So you can see here overall concept in RDT 2.0, stop and wait concept is used. What is stop and wait? Sender will send the data. Receiver, upon receiving the data, he must send either positive or negative acknowledgement. So so here our sender will not send a new packet or new data unless he receives positive acknowledgement for previously sent data. I hope it is clear. What is that? Sender should send the data. After sending the data, he will wait for the acknowledgement. Only if positive acknowledgement is received for the data, then only he can send the next new packet. If he is not receiving positive acknowledgement for the data, in that case he cannot send the new packet. He must retransmit that old packet only. So in this case, stop and wait means stop until you get a positive acknowledgement, or stop and wait for the positive acknowledgement to arrive. That concept is used in RDT 2.0. Okay, so that is the concept, and you can see here this is RDT 2.0 till now what we had discussed. So next this handling duplicate things is done in the next improvised version of RDT, that is RDT 2.1. Okay, I hope till here it is clear. RDT 1.0, RDT and RDT 2.0, and also the drawback in RDT 2.0, and also the concept of stop and wait. I hope it is clear.